Okay, so welcome back. Welcome back to the Calculus Analytic Geometry. What we discussed in our last class, we discussed about the different strategies to compute the integrals. We talked about that how to interpret the definite and indefinite integral in a variety of physical ways. And then we talked about integration by parts, and how to do the integration by substitution, why these tricks make sense, and how to basically do the calculation based on it. So I hope you got the essence of that. So what I'm going to do today, I'm going to talk about some more interesting techniques of what do you call computing the integral actually. So I will start with dealing with some techniques about solving the trigonometric integral, okay? Trigonometric integrals. So in particular, I will start with the case that when you have an integral of say sine x and cos x, okay, any one of them, but with the odd power actually, with some odd power. Okay? With some odd power, say of 2n plus 1, then how to integrate such kind of what do you call functions actually. There will be always a trick that would work if you have the sine and the cos function with the odd power actually, and nothing else with them. Okay, this is an important thing. So imagine that I want to compute, say for example, integral of sine cube x. The same trick would also work if you have say power 5 or power 7 and so on and so forth. Okay, so I want to demonstrate this for sine cube x actually. So how to do this? Okay. So what we can do when you have such situation, always take isolate one sine, one power of the sine, and rest of the even powers here. Okay, so in other words, write sine cube as say sine square times sine x. So if you're going to have sine power 5x, then you're going to write sine power 4 multiplied by sine x. So isolate the one power actually of the sine. Okay. Then what you can do, then you always have to use this identity. So if you are solving say sine's integral, then you're going to use this identity that sine square is 1 minus cosine square x, okay? And if you are, for example, solving the odd integral with cosine x, then you're going to use cosine square x is 1 minus sine square x. So if you're going to use this identity, what you're going to get? You're going to get 1 minus cosine square x times sine x dx actually. Using your previous techniques, you could try to solve this. For example, one formula that can help you in solving this integral is going to be the reduction formula that we did in the last of what do you call the integral. But you can do the same integral without reduction formula as well by this trick actually. Okay. So what we do now? I mean, if you think carefully about it, you can treat this as the composition of two functions. Okay? So you can treat this as a composition of two functions, and here you have the derivative present actually. So in other words, if I take for example f of x to be 1 minus x squared and g of x to be say cosine x, then f of g of x is going to be 1 minus cosine square x. So what is g of x here? The g of x is this cosine x, and you see that its derivative is present here. So you can make a substitution. You can make a substitution. Okay. So you have a cosine, and its derivative sine present here. So you can make a substitution. So how can I make a substitution? So I'm going to say that let t is cosine x, so that dt by dx is going to be negative sine x. Okay. Therefore, the dt is going to be negative sine x and dx. Now you're going to say there is no negative sign there, so it's not a big deal. I can, put a minus sign here and put a minus sign here actually. So in other words, I can, multiply the sine x with minus 1 multiplied by minus 1 actually. Okay? So you're going to get this. So once you have this, you are almost done because your function will almost become a polynomial. So it's going to be 1 minus, say, t square, and this minus sine x dx will become dt. So it's now a very simple integral actually. And what you're going to get is going to be minus, so the integral of this is going to be t minus t cubed upon 3 plus constant, and then substitute the value of the dummy variable, which is minus sine x minus sine cube x, okay, sine minus sine cube x upon 3 plus constant c. So that's this is what is the integral of sine cube x. So you can also think of what you call the higher power side. So try to also compute, for example, sine power 5x dx. So you're going to have a sine power 5x, here you're going to have a sine power 4, and here you're going to have 1 minus cos square, and hence you're going to have 1 minus t square. Then you can simplify this polynomial and then compute the antiderivative. So it's not going to be that difficult when you have the odd powers of the sine and cos and you want to integrate them. So try to compute similarly for the cosine cube x, and also compute this for the cosine power 5x. So that would be a good exercise of computing the trigonometric integral, okay, with odd power. Okay, the odd powers. One can naturally ask a question, okay, if there is a trick for solving the odd powers, is there a trick for solving the even powers actually? The answer is yes actually. So what if I have even powers of sine and cosine actually? So in other words, imagine you have this sine square x dx, or maybe sine power 4x dx actually. Okay, sine power 4x dx. And maybe let's just start with sine square x and then try to compute this integral. Then you have two choices. You can apply reduction formula and compute this integral, or in case of the even powers, there is something that always helps actually, which is called the half angle formulas actually. So I hope you remember the half angle formulas. So what are some of the half angle formulas? So the half angle formulas goes like this. So there are two half angle formulas that you always have to keep in head, that cos 2x is cosine square x minus sine square x actually. Okay? So this is the general half angle formula. But from this half angle formula you can derive two other half angle formulas actually. So in this, if I, for example, substitute on the place of cosine square x, I substitute 1 minus sine square x minus sine square x. So on the place of cosine square x, if you substitute 1 minus sine square x and minus sine square x, what are you going to get? You're going to get 1 minus 2 sine square x. And from this, you can compute the value of sine square x in the terms of cosine 2x. So what would be the value of sine square x in the terms of cosine 2x? So it's like bring this 2 sine square x on this side and cos 2x on the other side. So you're going to get 1 minus cos 2x. So if you have 2 sine square x, you can divide it by 2. So this is really the formula, the double angle formula or half angle formula, whatever you call it. Okay. So if you have an angle x here, you're going to get the double of this, whatever. So if you have a 4, you're going to have 8. If you have a pi, you're going to have 2 pi. If you have, say, 2x here, you're going to get 4x here. Okay. So the double angle formula. You can also derive a similar formula for cosine square x actually. Okay. You can also derive a similar formula for cosine square x by substituting the value of sine square x here. So when you're going to substitute the value of sine square x here, cosine 2x, okay, cosine 2x is going to be cosine square x minus sine square x is 1 minus cosine square x. If this is the case, then this will become minus plus minus and minus minus plus, so it's going to be 2 cosine square x minus 1. And hence, what would be the value of cosine square x? So the cosine square x is going to be 1 plus cos 2x and divided by 2. So the difference is really minus. So in sine square x, you have 1 minus cos 2x upon 2. In cosine square x, you have 1 plus cos 2x upon 2 actually. Okay. And there is also a formula for what we call sine 2x. And the formula for sine 2x is really 2 sine x cos x. This is also a useful formula in some situations. But if you have even powers of, say, integral, okay, so you have like this cos power 4x dx, you can apply, these two formulas actually. So for example, let's solve one example based on it. Okay, let's solve one example based on it. So for example, if I say that let's solve sine power 4x, do a bit difficult. Sine power 4x dx. And I know that I can write sine power 4x as sine square x square, and for sine square x you can apply this identity, which is going to be 1 minus cosine 2x over 2 and the square actually. Okay? 1 minus cosine 2x and cosine square. So if you simplify this a little bit more, this 2 will become, what do you call, 4, and this will become 1 plus cosine square 2x minus 2 cosine 2x. Okay. This is what it will be. So this is what is really what we call sine power 4x dx. And now if you integrate both sides, okay, if you integrate both sides, you're going to have something interesting. I wish you can keep this 1 over 4 outside, and you're going to get if you wish, you can also break it down actually, so you can say that I have 1 dx, okay, plus cosine square 2x dx and minus 2 times of here minus 2 times of cosine 2x dx. So you can solve it in this manner. And now simplify the integral. So what you can do, if you have such situation, you can calculate all these 3 integrals separately and then substitute it. If you can directly calculate them, yes, good. I mean, if you can't, then calculate the integrals separately and substitute their values here. So for example, what would be the integral of 1 dx? So it will be x actually. Simple. What will be the integral of, for example, cosine 2x dx? So you remember yesterday we did that, okay, if you have, say cosine of ax plus b type integral, then what would be the integral of this? So it's going to be sine ax plus b divided by the constant, the coefficient of what do you call x. So the sine 2x is really, you can do it in this manner actually, or you can make a substitution. I mean, if you had a hard time, just make a substitution actually. So take t equal to 2x. So the dt is going to be 2 dx. So what you need to do here, so you have to kind of multiply by 2 and divide by 2, okay? And then with this substitution, this will become cosine t, and this will become, these 2 terms will become dt. And then you can integrate 1/2 cosine t is sine t, and t is really 2x actually. So you get what you want. So we got the value of the integral that we required here actually. Now let's carefully think about the cosine square 2x. Okay, cosine square 2x. Again, this is like the integral of the even power of trigonometric function. And whenever you have to do the even power of trigonometric function, try to get rid of this even power actually. And the recipe to get rid of the even power is to use the double angle formula. And what is that formula? That if you have cosine square of, if you have cosine square of W, this is going to be 1 minus 2 times of, or 1 plus 2 times of cosine of, 1 plus cosine of 2 times of W divided by 2 actually. Okay, that's what is really the formula. So this, in this formula, if you put, for example, this W equal to 2x, then this will become 2x and this will become 4x actually. So cos square 2x is really 1 plus cos 4x upon 2. So you can substitute this here. You can say that, okay, let's calculate 1 plus cos 4x upon 2 dx actually. And then integrate. You can pull this 1/2 out of integral. The integral of 1 is going to be x. What would be the integral of cos 4x? So like this, the integral of cos 2x is 1 upon 2 sine 2x. So the integral of cos 4x is going to be 1 upon 4 and sine 4x actually. Sine 4x. So essentially what you did, you computed the all 3 integrals. Okay? Computed all three integrals. Take these integrals, substitute them here, and whatever result is coming is the integral of sine power 4x. Okay? Of the sine power 4x. So we saw that if you have even and odd powers of sine and cosines, how to compute such integrals. Another question could be that what if you have a mix of odd and even powers? In other words, imagine you have like say sine square x and cosine square x dx, or maybe cosine cube x and dx. Then what to do? So that's the mix. So one power is even and the other is odd actually. Then really the trick is that to break the odd power, in other words, sine square x and make it say cos square x times cosine x and dx. So break the odd power. And in the time, on the place of cosine square x, put the identity. So I can put the identity, so you're going to get sine square x 1 minus sine square x cosine x and dx. Now you have sines expression with sines and cosine multiplied with it. So in other words, like you have sines and their higher powers and cosine multiplied, so it's like its derivative is multiplied. So the essentially trick is that convert the odd and even power in the terms of say one function, and you should have only one power of what do you call the other trigonometric function actually. So you have to just get rid of everything else except the one power of variable. So for example, instead of sine square, if you're going to have sine cube and cosine square x, you would have done sine squared sine and cosine square x. Okay, and then convert everything else in the terms of sine x actually. What would be the benefit of it? That now you can make a substitution. You can assume this as a composition of algebraic function with trigonometric function. So let's take, say for example, t equal to sine x. So that dt by dx is going to be cosine x, okay, cosine x and dx. So see that what miracle happened with this substitution actually. So this will become t square, this will become 1 minus t square, and this will become dt. So see how radically your expression is satisfied actually. Okay, how radically your expression is satisfied. So now you can write this as t square minus t power 4 and dt. Simplify, integrate this function easily, and then replace back the value of t, and that would give you the integral of the situation when you have the one even power and one odd power actually. Okay, one even power and one odd power. What if the both powers are even actually? What if the both powers are even? In the both powers of even, so if you have for example the situation, okay, if you have for example the situation when the both powers are even, you have several ways of doing it. say sine square x and cosine square x dx. Okay. If the both powers are even, use the double angle formulas actually. So what is the formula for sine square x? So it's going to be 1 minus cosine 2x upon 2, and this is going to be 1 plus cosine 2x upon 2 dx. Let's just substitute this back. When you're going to simplify, what you're going to get? You're going to get 4, and this will become 1 minus cosine square 2x dx. You can write this as so 1 minus cosine square is like sine square 2x and dx. So again you got a sine square. But that's not a big deal because I can again apply what you call the double angle formula, and you're going to have 1 over 4. So what would be the equivalent expression for sine square 2x? So it's going to be 1 minus cosine of the double angle of this, so it's going to be 4x divided by 2 and dx. Then you know how to solve this integral actually. Okay? So now you can pull out 2, so this will become 1 over 8. The integral of 1 is going to be x. Integral of cosine 4x is going to be sine 4x divided by the coefficient of x, in other words 4. Okay? So that's how you can deal with if you have the even powers actually. Okay? So the same trick would still work if you have higher even powers. So if you have like sine 4x and say cosine 4x. Okay? So the same trick would still work actually. Okay? The same trick would still work. That no matter what even powers you have about sine x actually. Next, I would like to talk about making the trigonometric substitutions. So yesterday I solved one problem and left one integral, in the solution, and I said that we will learn how to compute such kind of integrals. So we will basically talk about how to compute those type of integrals actually. So if your integral involves, say for example, this kind of expression, a square minus x square, or a square plus x square, or x square minus a square. Okay? So if you have an integral which involves this kind of a function, okay, so it's like it could be this function or it could be something in numerator or in denominator, always the trigonometric substitution would work if you have, integral involving square root of a square minus x square, a square plus x square, and x square minus a square. So what kind of trigonometric substitutions should we make actually? Okay. So let's just start with, for example, first. Let's compute a square minus x square, where a is some constant actually. So you can have a situation, say square root of 4 minus x square, then your a is like 2, because you have 2 square minus x square. You can have a situation square root of say 3 minus x square. There is no square here, but you can choose a to be square root of 3. You can write it as a square root of 3 square minus x square. So if an integral, of a function involves a radical sign with square of a constant minus a square of a variable actually, then how to solve such problem actually. So in this case, you can always make one substitution either. So you have to make a kind of a trigonometric substitution. Okay? Trigonometric substitution. So for solving such problems, you have to do the trigonometric substitutions actually. Okay? So what kind of substitution you can have?